Welcome to Section 5.2, Proving that Lines are Parallel. The objective of our lesson is to apply the exterior angle inequality theorem and use various methods to prove that lines are parallel. For our homework, we're going to be working on page 219 to 223, numbers 1 through 2, 5, 11 through 13, 16, 20 through 22. So our first theorem. The measure of an exterior angle of a triangle is greater than the measure of either remote interior angles. Now, first and foremost, it's important to know what we're talking about here. So let's refer to this picture. Our exterior angle is located outside of our triangle. It has an adjacent interior angle, adjacent meaning right next to it. Now, remote, if you think about if you're going camping in a remote place, you're going kind of far from everything. These are your remote interior angles, or your RIAs. Your remote interior angles are not attached or not adjacent to the exterior angle. So if we call our exterior angle X, those remote interior angles Y and Z. Here's what our theorem says. The measure of the exterior angle X is greater than either remote interior angle. So X is greater than Y, and X is greater than Z as well. So here's our next theorem. If two lines are cut by a transversal such that two alternate interior angles are congruent, then the lines are parallel. Now, you can either write out that long theorem or we can abbreviate it. Alt, int, angles, congruent, yield parallel lines. That's what I would do. So here's what our picture looks like. Let's call this line A, this line B, and our transversal we're going to call T. Now, if we know alternate interior angles are congruent, so that's a given to us, or somehow we can deduce that. If we know these two angles are congruent, the next thing that we can say is line A is parallel to line B, because if alternate interior angles are congruent, then the lines are parallel. So here's our next theorem. If two lines are cut by a transversal such that two alternate exterior angles are congruent, then the lines are parallel. Or in shorthand, alt x angles congruent yields lines parallel. So let's call this C, let's call this D, and again let's call this T. If we know those alternate exterior angles are congruent, so this is given information to us, we can then say that line C is going to be parallel to line D using our new theorem. Alternate exterior angles are congruent, then the lines are parallel. Okay, our next theorem. If two lines are cut by a transversal such that two corresponding angles are congruent, then the lines are parallel. Or again, in short, core angles are congruent, yields parallel lines. So here we can have any pair of corresponding angles. We can have the upper left congruent to the upper left, the upper right congruent to the upper right, the lower left congruent to the lower left, or the lower right congruent to the lower right. We need one pair of those angles to be congruent, and once we have that, let's call this line X and call this line Y. Again, we'll call this transversal T. Once we know one single pair of corresponding angles are congruent, we can say our lines are parallel, because if corresponding angles are congruent, then our lines are parallel. In our next theorem, if two lines are cut by a transversal such that two interior angles on the same side of a transversal are supplementary, the lines are parallel. Now, I want you to come up with a shorthand for this. What do you think we can shorten this theorem up for? Think about it. Here's what I would have. I'm going to call these same side, interior, angles, supplementary, yields parallel lines. That's how we're going to shorten that up. So here we go. Let's call this line E, let's call this line F, and again transversal T. Now, here's what we have to know. Let's call this angle 1 and this angle 2. Let's say we're given, or we can deduce, that angle 1 plus angle 2 equals 180. Or we're just given angle 1 is supplementary to angle 2, either one. If we know either one of these pieces of information, we can say E is going to be parallel to F. Because if same side interior angles are supplementary, then lines are parallel. Our next theorem. If two lines are cut by a transversal, such that two exterior angles in the same set of transversal are supplementary, the lines are parallel. Again, what are we going to shorten this up to? Here's what I would have. Same side exterior, angles supplementary, yields parallel lines. So again, let's number our angles. Let's call this angle 1 and angle 2. Again, if we know angle 1 plus angle 2 equals 180, or we're just given that angle 1 is supplementary to angle 2, let's call this line G, let's call this line H, and again transversal T. As long as we know one or the other, we can say that G is parallel to H, because if same side exterior angles are supplementary, then our lines are parallel. And our last theorem. If two coplanar angles are perpendicular to a third line, they are parallel. So here we go. Let's draw this one out. Let's call this line A, and let's call this line B, and again transversal T. If we know or can deduce that A is perpendicular to T and B is perpendicular to T. So again, if we know that we have two separate lines that are perpendicular to the same line, we can then deduce that those two separate lines are parallel to each other using our theorem, which is not going to have any shortcuts. Two coplanar lines are perpendicular to the third line, they are parallel. Okay, now we got some examples. I know, you've been dying to do some of these bad boys. So here we go. Our first example. We're given that AB is perpendicular to BD, and CD is perpendicular to BD. We're trying to prove that AB is parallel to CD. I actually think you got this one on your own, so let's see what we can do. Press pause and have at it. Okay, here we go. We got our statements and our reasons. You can either combine those givens or write them as one statement. I'm going to write them separately. AB is perpendicular to BD. CD is perpendicular to BD. Those are all given to me. And this is going to work similarly to our transitive property. We see those BDs are going to cross out. The difference is that transitive only works within congruency. Once I see that we have repeats amongst perpendicularity, I can go straight into saying that AB is parallel to CD using that last theorem. I can say, if two lines are perpendicular to a third line, they are parallel. Hopefully you got that one. Here's our next one, slightly more difficult. And we have some background information about this. Anytime there's information regarding a proof that we haven't learned yet, they'll usually give us a little piece of background information like we're going to give here. A parallelogram is a four-sided figure with both pairs of opposite sides parallel. So here we go. We're given angle 1 is congruent to angle 2, and angle PQR is congruent to angle RPS. We're trying to prove we have a parallelogram, which means we're trying to prove that we have both pairs of opposite sides parallel. So let's get going. Our statement and our reasons. We're given that angle 1 is congruent to angle 2, and angle PQR is congruent to angle RSP. Those are going to be our givens. 1 is congruent to 2, and this bigger angle, angle PQR, is congruent to angle RSP. The first thing I'm going to think right here is I have big angles congruent and a little angle congruent, so let's do a subtraction property. Angle 3 is congruent to angle 4 by subtraction. to mark it in. Angle 3 is congruent to angle 4. Now, I want to look at those congruent angles. 1 matched with 2 and 3 matched with 4. For me, the easier one is the 3 matched with 4. I want to trace over those angles. Here's my angle 3. Here's my angle 4. See how they have that common overlap? That common overlap is their transversal. So here's what I'm going to do. I'm going to take a highlighter here, and I'm going to go over those lines. And I'm going to extend them. There's one line extended, so I don't stop at that vertex. Here's my other line. And here's my transversal, the common line. When I look at angle 3 and angle 4, they are actually located inside. Make those darker. Here's 3, here's 4. They're located inside of my parallel lines and on alternating sides of those transversals. Makes those things alternate interior angles. What I can say is those two extra lines, QR, is parallel to PS. And the reason, if alternate interior angles are congruent, then lines are parallel. Now, let's erase some of that. So next, let's deal with 3 is congruent to, 1 is congruent to 2. So let's look at those. So if I know that angle 1 was congruent to angle 2, let's look at the angles that make that up. Here's angle 1. Here's angle 2. Do you see what the transversal is? The transversal is QS. So what are the other two lines that make it up? PQ and SR. I'm going to highlight them. Here's PQ. Here's RS. And here's that common transversal. So here's what we got. Angle 1, angle 2. They're inside. They're smashed in the middle of my blue lines. And on alternating sides of my transversal, one bottom, one top. That makes them alternate interior angles. With those blue lines, we can say that PQ is parallel to RS. For my reason, same as number 4. If alternate interior angles are congruent, then lines are parallel. So last but not least, I can say PQRS is a parallelogram. My abbreviation for a parallelogram is PARL, for a reason. If both pairs of opposite sides of a four-sided figure are parallel, it's a parallelogram. Hopefully you got that. If you don't, make sure you make a little note of that right now, and we'll go through more examples tomorrow in class about this. Okay, here comes our last proof. Again, we got a little bit of background knowledge here, so let's make sure we make note of this. Trapezoid is a four-sided figure with exactly one pair of parallel sides. Now, I want to see what we can do here. Try it. If you need a little help, just unpause it and see how far you can take it on your own. Press pause and let's have at it. So here we go. Got our statements and our reasons. We're given that angle 1 is supplementary to angle 3, so these two. That's not so good, they're definitely on the same line. And we're also given that angle 2 is congruent to angle 3. Those are our givens. And that's kind of crazy because we're on two different lines with two different transversals. Now, here's the lines I kind of want to be parallel. I'm going to go over this with my highlighter. I kind of want this line here, and I kind of want this line here. Now, if I look at what we have inside of those lines that I kind of want to be parallel, I got these two angles here, 1 and 2. It'd be nice if I can get them to be supplementary, and you know what I can? Anytime I have congruency, I can replace one angle for the other. So that's what I'm going to do. I see that I have angle 2 is congruent to angle 3. So I'm going to take that angle 3 from the step before and I'm going to replace it with angle 2. Now I'm going to say angle 1 is supplementary to angle 2 by my replacement step, which is the substitution step. Now, let's look at those two angles. Those two angles, they're on the same side of the transversal, inside of my lines, which makes them same side interior angles. And I know that if same side interior angles are supplementary, then my lines are parallel. So I'm going to say that RA is parallel to TP. If same side interior angles are supplementary, then my lines are parallel. If exactly one pair of lines are parallel, and those arrows that I'm drawing on there actually signify parallel lines. So once I know that I have a pair of parallel lines, I can say I got a trapezoid. TRAP is a trapezoid. And my reason is if one pair of lines of a four-sided figure are parallel, then I have a trapezoid. Hopefully we got that. And here's my last example, writing restrictions on my inequality. So here's what I got here. I have an exterior angle, that's my 3x minus 18. Here's my adjacent angle, which makes 30 a remote interior angle. And here's one of my restrictions that I know. I know that my exterior angle is definitely going to be bigger than my remote interior angle. So let's solve for that. Let's add 18 to both sides. 3x is greater than 48. Divide both sides by 3, which means that my x is going to be greater than 16. Now, what restriction am I bound by? Let's think about that for a second. I definitely know that angle, or any angle for that matter, definitely has to be under 180 degrees. So I have a second boundary here. I have that 3x minus 18 is definitely have to be less than 180. So here we go, let's go ahead and solve that. Let's add our 18 to both sides. And we have 3x is less than 198. Let's divide both sides by 3, and my x has to be less than 66. Now if I want, I can leave that as these two separate inequalities. Or if I want, I can combine that into one compound inequality with x in the middle. X has to be greater than 16, but has to be less than 66. Hopefully you got the hang of those restrictions a little bit, especially with how the exterior angle is going to relate to that interior angle. Last but not least, here's our homework answers. So we had again 1, 2, 5, 11 through 13, 16, and 20 through 22 for homework. You'll see that the proofs themselves are pretty short, and a lot of times all I want you to do is just justify why those lines are going to be parallel. So take it for what it's worth. Do a good job on this though. Make sure if you have questions, we're asking about them tomorrow in class. Have a good one.